In a classroom, the way it works is that a professor comes in Monday and says, students, today is Monday, we're going to learn this. Then the next day, this is Tuesday, we're going to learn this. Then he comes in and says, it's Friday, we're going to have a test to see if you learned all the things you're supposed to learn. IGEM works a completely different way.
In this project, you basically start off on a whiteboard. You can basically put in whatever you want, and it's your project. You can make it go wherever you want.
This is not just biology students. This is computer science students. This is engineering students. This is mechanical engineers and space scientists. All of them contributing in some way or another to the kinds of projects that we're seeing here.
Well, to be honest, I think it's something like my childhood dream, even before I heard the name. When I first heard that there is a subject called synthetic biology, and then I thought, well, this is exactly what I was looking for, so I have to get involved somehow, and IGEM is a great opportunity for that.
The enthusiasm is contagious. It's always the case that the most exciting things happening in science happen at those interdisciplinary boundaries.
I started IGEM. I didn't know anything. I didn't know proteins were made out of amino acids, but I started working and eventually began to fall into place. I get more interested, and anyone can do this. This isn't limited to people who want to do synthetic biology. You can be any major. Just do IGEM. It's amazing.
Because IGEM is based on a get and give. So normally you have to give something to get something, but in our world, we give you the parts, we give you the information, but you're expected to give back.
The thought that what I think of and give to the world is going to make a difference to a lot of people. To be able to use up right after what I finished working on is a great thing. I think of something, work on it, and give it to the world, and the whole world can use it now.
The students in IGEM are figuring out what they need to know and what they need to learn in order to meet their goals, and that is so much more exciting and produces such a stronger learning environment that it's completely different from an internship or a normal course.
It's like we created a project and we carried it through, and we're now presenting a project that we did and we made.
I'm always very impressed by the creativity of students. When they're given an opportunity to think about things outside of the box and try to challenge themselves to do both new science and also apply that to new applications, they come up with fantastic things.
Our hope was to develop synthetic biological systems for space application and for space exploration.
Therefore, our cells are...
We wanted to engineer bacteria to move towards the roots of plants and move inside the roots of plants where they can deliver plant growth hormones to improve root growth.
We tried to eliminate usage of antibiotics and brought up a new mechanism in which this process can be addressed.
This is not just about some cool technology or some new idea and some great science. All of those are important, but it's also making sure it's framed in a context of doing the right thing for society, being cognizant of potential risks, and taking steps to prevent problems.
I think that the best way to inspire young children in science is not necessarily to tell them anything, but to let them be exposed to some sort of problem and then to ask them to solve it.